Hello everybody, this is a review for imaginary and complex numbers. You need to remember for this that we use the symbol I to represent the square root of -1. There's an example here for you. You can go ahead and read it through. It just gives you a quadratic equation, which is when you want to use I, or when you might see I, in solving for solutions that don't have real solutions. So we have the square root of -1 needed to get solutions that we can call imaginary. These are represented by I, and sometimes a coefficient is included in front of that I. That coefficient by itself is a real part. I is the imaginary part. Put them together and you have imaginary numbers. So these here are examples for you of imaginary numbers. All right, we want to get right into complex numbers, which include two parts: a real part, represented by A, and then the imaginary part, where you have a coefficient with I. Put together, these make complex numbers, so there are two parts to those. When we write a complex number, we write them in standard form. That means that the real part comes first, followed by the imaginary part. Technically, every number is a complex number if you consider that the real part could be 0 or the imaginary part could be 0. So they give you some examples here that you can take a look at, but I don't want to spend time on those because I think most of you have an idea what complex numbers are. So we're going to go ahead and move on down and start to understand what happens if we have I and we raise it to a power. Because when you have the square root of -1 equaling I, if I square I, it means I'm squaring the square root of -1, which gives me a value of -1. So if I take I to the second power, I get -1. If I take it to the third power, I to the third power, it's I squared times I, which is the same as -1 times I, or -I. Start to see a pattern going on here. So I squared is -1, I to the third is I to the fourth is the same as I squared times I squared, or -1 times -1, which equals 1. Your cycle is going to repeat. You are going to get solutions of I, -1, -I, 1, and then again I, -1, as you increase the power that you are bringing I to by 1. Because this is cyclic, it means we have this pattern going on. It's cyclic, but it's repeating. So 4 terms repeat over and over again. And the nice thing is, if you're using the Inspire, you can take I to any power, throw it in your Inspire, and it's going to give you the actual answer, one of these 4 terms. Let's then take a look. Up here is the same cycle shown for you. What we want to remember when we are working with I, always I squared is -1. I equals the square root of -1. One thing you want to look out for when you are simplifying radicals, if I have something like radical -4, that is equal to the square root of -1 times the square root of 4, and I can replace that with I times 2, or 2I. However, if I have two radicals that I am multiplying, I need to be careful if they're both negative. I first want to simplify individual radicals like this one here to get the terms in I. Here's where you might have a problem. Supposing I'm taking negative 4 under a radical and I'm multiplying that by radical negative 25. Do not multiply these first and keep them under a radical. In other words, don't make this into negative 4 times negative 25 is a positive 100, and then say that that is 10. That actually is not the case. Think of it this way. If I have a negative 4 under a radical and I'm multiplying it by radical negative 25, simplify first using I. In other words, this radical negative 4 becomes 2I, and the radical negative 25 becomes 5I. Multiply those together, we get 10I squared. Replace 10I squared with 10 times negative 1 because negative 1 is equal to I squared. This gives me a negative 10 and not the positive 10 that I would have gotten if I'd combined my radicals first. So just look out for that. Do not multiply these first when you have negatives under the radical. Okay, this is the cycle again shown for you, and then shows you what happens when you have I brought to higher powers. And we're going to look at how we simplify that without using calculators. But please be aware, these are very easy to put into your calculators. If you have an Inspire, it's going to give you the correct answer right away. If you're using a TI 83 or 84, it gives you something with an E in there, and you have to learn how to interpret that into the right answer, or do what I'm going to show you next and understand how to get those values without using a calculator. So a couple ways you can do this. Two ways that we can simplify something where you have I to a higher power. One way is to take that exponent. In this example, we've got I to the 83rd power. If I take that 83, and I want to see how many times I have 4 in that 83, because I to the 4th power is equivalent to 1. So I'm really seeing, okay, if I have an exponent of 83, then I have possibly I to the 4th, I to the 4th, I to the 4th, some number of times. And then whatever my remainder is, in this case, 3, so I'm dividing 83 by 4, I get 20, the remainder is 3. Really, this I to the 83 is equivalent to 1, that's my I to the 4th, 20 times, so to the 20th power, times I to the 3rd. So this means 1 to any power is 1, so really my answer is just I to the 3rd, or whatever that equals, and we know that that is equal to negative I. This other example here shows you exactly, if you break down that I to the 83rd power to terms of I to the 4th, we have I to the 4th 20 times, or to the 20th power. This is all equal to 1. And then we have multiplied times I to the 3rd, which is negative I, giving us that same answer of negative I. Alright, I think we are good to keep going here. One thing I want you to note, this is something that I see a lot of students get caught up in. We said at the beginning that you see I occur when you are solving quadratic equations. So that means you're dealing with x squared, and when you're solving, you are taking the square root. Be careful. You only pull out the square root of negative 1 and let it equal I. You cannot do this, so I will not equal the cubed root of a negative 1, because in fact the cubed root of negative 1 equals negative 1. Do not mix these up. So if you're working with cube roots, do not try and pull out an I from there. Okay, give you one more example. Let's say you are finding the cubed root of negative 64. Do not think that I'm going to pull out the square root of negative 1 as an I, and then tell me that the cubed root of 64 is 4, and give me something like this. This is not true because the cubed root of negative 64 is equal to a negative 4. Roots with odd numbers can have solutions that are negative. If you have a root, excuse me, if you have a root that's a even number, then you're going to see I involved. All right, hopefully my throat will clear up here and we can keep going. All right, we're going to look at how do we add like terms when we have I involved. Very simple, really. If we're adding, we add the real parts of our complex numbers, and then we add the imaginary parts together. And write our answers in a plus bi form or standard form. Okay, so let's take a look and suppose that we have just letters, just to make it, I guess, complicated. Let's say I'm adding this complex number where the real part is m and the imaginary part is ni, so this is a complex number. And I'm adding it to another complex number. The real part is p, imaginary part is qi. I take the real parts and add those together, so I add m plus p, put that down first to be in standard form, and then add together my imaginary parts. And you can think of the I in this as kind of like an x or some kind of variable. All I need to do is add my coefficients and put the I afterwards. So really, this will be the real part plus the coefficient that is the n plus q followed by I. All right, let's look at a few examples here. And keep in mind also, these you can put into your calculators if you change the settings to be working with complex numbers. So just a note on this. You can do these on your calculators, either the 83s, 84s, or Inspires. You just need to change your settings to work with complex numbers. It will default to working with just real numbers. You can change that. But let's do these by hand. I've got a complex number 7 plus 5i added to 8 minus 3i, so I'm going to put together my real parts. 7 and 8 is 15. And then I'm going to add together the imaginary parts. So 5 and a negative 3i gives me a negative 2i. And that's done. Going on to example number 2, I'm going to add my real parts. 2 and negative 8 gives me negative 6. And then add my imaginary parts. Gives me a negative 3i. Pretty straightforward. Let's look at this next example, though, where we've got some radicals with negatives. This means they're not given to us in simplest form, so we need to take these radicals and we need to simplify them. So 3 plus a radical negative 64, well, 64 has a square root, that's 8, and then the negative 1 comes out as an I, so this is the same as 3 plus 8i, and I'm adding that to 10 minus radical negative 25 will be 5i. So now adding these together, I add the real parts and I get 13, add the imaginary parts, and I get positive 3i. One more solution, or one more example here. I'm going to take my real parts, add those together, get negative 2, and then my imaginary parts. When I'm adding imaginary parts, I can only combine them as like terms if everything after my coefficient is exactly the same. So here I have a coefficient of 7, and here it's negative 6. In order to add those together, everything else has to match. So here I have I radical 2 and another I radical 2. So they are like terms, and I can add together. 7 and negative 6 gives me 1, so I have a positive 1 of these I radical 2's. That gives me my answer there. Alright, let's move on to subtracting these. Pretty much the same thing, only we have to remember when we are subtracting, we are going to distribute our negative sign just like we do for any polynomial that we are subtracting. So here I'm going to take my real parts, 5, and I'm going to subtract 2, get 3, and then I'm going to take my positive 8i and subtract 2i here, and I will get 8 minus 2 is positive 6i. For this next example, I've got 8 and oh wait a minute here, I'm subtracting this first complex number from the second. So what I have here then is, I'm going to write this now as an equation. I'm starting with 9 plus, I'm going to simplify this to be 6i, and I'm subtracting this 8 minus, and I'm going to change my radical negative 100 to 10i, and remember to distribute my minus sign here. So I have 9 minus 8, which gives me 1, that's these real parts, and 6i minus a negative 10i becomes 6 plus 10i, or plus 16i. Similarly, this next one says to subtract this first binomial complex number from my second one, so I'm going to rewrite this one. And from that, subtract 7 plus 3i radical 5. Now it looks like I have like terms here because after the coefficient, I have I radical 5. So those are like terms, I can combine them. So I'm going to take the real parts, negative 9. I'm going to subtract 7 and get, excuse me, listen to the announcements here.
Good morning, middle level. Today is Wednesday, January 27th, cycle day number 1. Please rise and join me in the pledge of allegiance. Pledge of allegiance to the flag of the United States of America, to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. 6th grade boys, last day makeup, 27th, swim makeups today, 2:30 to 3 o'clock, Coach Walsh. So 6th grade boys, last day to make up swim class, 2:30 to 3 o'clock, Coach Walsh. Brief GAL meeting, committee, that's enough for junior high. I don't really have a lot of junior high. I don't have a joke off the top of my head. Mr. Gallman's lessons are canceled for today. Mr. Gallman's lessons are canceled for today. Boys, if you're interested in JV varsity baseball, sign up for a week training hitting camp, please, in Mr. Dom's PE class. And applications for Mr. Gallman to the Triad Music Honor Society. That's all I think I have for middle level, so let's make it a great day, folks.
Okay, here we're going to multiply two complex numbers. I've got 2 plus 3i multiplied by 4 plus 5i. So I would use the box to multiply so we can see all the terms. I filled those in here. One thing you want to make sure you realize, when you get an I squared, like over here, you want to replace that with a negative 1. I squared is equal to negative 1. So I really have 15 times a negative 1. I'm going to make that a negative 15 and eliminate my I squared there. So now when I combine like terms, diagonal terms in the box should be like terms. So I have an 8 and a negative 15. That gives me negative 7. And then I have 10i and 12i to add together, which gives me a positive 22i. Now when you multiply, take the product of two complex numbers, your answer is going to be a complex number, unless you are multiplying complex numbers that are conjugates. If that's the case, then the imaginary part will drop out, and if you are multiplying conjugates, your answer is going to be real. So your answer is real only. No imaginary part if you are multiplying conjugates, where the imaginary part is the second part of your conjugate. Alright, so let's take a look now at when we divide complex numbers. And this is where we're going to make use of multiplying by a complex conjugate and having our answer be real. If we are dividing complex numbers, if I write it like it is a fraction, 4 plus 2i over 3 minus I, just like with radicals, we cannot leave imaginary parts in the denominator. So we cannot have denominators. That are imaginary. So we have to do what's called rationalizing that denominator, just like we did when we had radicals, which means we need to multiply that fraction by something that will eliminate the imaginary parts in the denominator, which comes in very handy knowing that if we multiply by a conjugate, we only get a real answer. So this division, 4 plus 2i over 3 minus I, can be rationalized if I multiply top and bottom by the conjugate of my denominator. So that would be times 3 plus I. So when I do that, in the denominator I will only get a real solution. And in the numerator, because I'm multiplying complex numbers that are not conjugates, I'm going to get a complex number, and that's okay. So I'm going to multiply first the numerator. I'm going to use the box and do 4 plus 2i multiplied by 3 plus I. I get my I squared term in there and I want to make sure I change that to a negative 1. So it's 2 times a negative 1 or a negative 2, which gives me a complex number. I'll put that together in a moment. My denominator, I'm multiplying conjugates. 3 minus I, 3 plus I, which gives me 9. My 3i and negative 3i will cancel, and I have a negative I squared, which I'm going to replace with a negative 1. And now I'm going to combine like terms. So back to my numerator, I have 12 and negative 2, which gives me 10 in the numerator. And in the denominator, forgot my imaginary part here, plus 10i. And in the denominator, my imaginary terms canceled, and I have 9 and a minus 1, which gives me no, I've got a mistake there. Sorry for that pause in here. Negative I squared. The I squared part is replaced with a negative 1, but I really have, didn't mean to move that, I really have a negative 1, which becomes a positive 1. So when I combine that with my 9 and a positive 1 gives me 10. I'm going to simplify this fraction. I can divide 10 out of every term, not just part of my fraction, part of the numerator. And divide 10 out of this denominator and first term here in my numerator. I can't just divide it out of part of my numerator. I've got to do every term in my numerator. Gives me a solution of 1 plus I over 1, which is the same as 1 plus I. Again, you can do these in your calculators. Just make sure you change the settings so that you can work with complex numbers. And then if you have to do other calculations after that, you want to change your settings back to real numbers. Alright, that'll do it for today. If you have any other questions, please come see me before the midterm. Have a great study session, guys, and do well. Bye.